Indonesia is building a modern industrial powerhouse at breakneck speed, but powering that growth has a massive vulnerability. The country imports millions of barrels of expensive foreign fossil fuels to keep its economy running. To cut that dependency, the government is replacing fossil diesel with plant-based energy. They're rolling out a national mandate to power the country with a domestic B40 blend, meaning 40% is refined from locally grown palm oil. By growing its own energy, the country keeps roughly $8 billion a year inside its own economy, rather than sending it overseas. At the same time, this switch strips tens of millions of tons of carbon dioxide out of the atmosphere. This is an economic defense mechanism. Cultivating fuel is a deliberate strategy designed to insulate a rapidly developing nation from volatile global oil shocks. But pumping thick, viscous plant oil into a high-pressure diesel engine immediately lowers combustion efficiency and causes mechanical friction. The core engineering hurdle is that biodiesel is hygroscopic. It chemically attracts microscopic water molecules from the humid air. Inside a fuel tank, this trapped water rusts internal components and breeds biological sludge. When temperatures drop, that sludge thickens, choking the fuel filters. To keep massive mining trucks moving, crews must enforce rigorous, expensive service protocols, draining water from tanks and swapping filters far more often than normal. A nationwide energy policy might look perfect on a spreadsheet, but it lives or dies based on the fluid dynamics inside a commercial diesel engine. While heavy industries are learning to adapt on the ground, using advanced synthetic lubricants and constant lab-grade oil monitoring, the sky presents a much harder problem. Due to the extreme energy density required to lift hundreds of passengers into the air, commercial aviation remains the single most difficult transportation sector to run on renewable energy. Indonesia's solution to this challenge is Sustainable Aviation Fuel, frequently called Bioaftor, which is already being formulated and pumped into commercial aircraft. Instead of feeding high-quality food-grade palm oil into jet engines, scientists are taking a far more efficient approach. They are actively hunting for the agricultural industry's trash. When raw palm fruit is pressed, it leaves behind a highly toxic, heavy liquid waste known as Palm Oil Mill Effluent, or POME. Engineers are taking this sludge and applying a chemical refining method called the HEFA process to strip away impurities, converting raw waste into clean-burning jet fuel. Decarbonizing the aviation sector doesn't require clearing land to plant millions of new trees. It requires capturing the toxic byproducts of the existing agricultural system and upgrading them into high-value energy. Driving that kind of demand for both road and jet fuel requires an immense physical footprint. This sheer scale draws intense international scrutiny over the threat of deforestation and the clearing of native ecosystems. The nation sits at the center of immense geopolitical pressure. They have to balance the highly lucrative global export market for raw materials with the immediate need to feed and power their own population. To protect the environment while maintaining this economic engine, regulators enforce ISPO certifications. This system rigorously audits the supply chain to penalize illegal land clearing and ensure crops are grown responsibly. The government also instituted revenue-sharing funds, ensuring that a strict percentage of export wealth flows directly back to local provinces, building infrastructure and supporting the smallholder farmers working the soil. Environmental protection cannot work in a vacuum. A green revolution only endures if it protects the local ecosystem while simultaneously generating wealth for the people who manage it. The engineering potential of the palm ecosystem extends far beyond liquid fuels for trucks and planes. It is now actively being tapped to expand the nation's rural electrical grid. Engineers pump liquid waste into sealed digesters, trapping flammable methane gas to spin turbines and generate rural electricity. Finally, the crushed organic shells and the solid woody fibers are continuously fed into high-efficiency biomass power plants. Relentless engineering has transformed the palm tree into a fully integrated, zero-waste power plant. This national transition is a gritty, complex process, filled with mechanical breakdowns, serious ecological risks, and billion-dollar economic gambles. But while many developed countries are still debating the theories of renewable energy, Indonesia is building the physical infrastructure. They are testing the technology in real time, absorbing the mechanical friction and forcing it to work at scale. By securing energy independence from the ground up, economy can transition